BitNet, scaling 1-bit transformers for large language models. The increasing size of large language models has posed challenges for deployment and raised concerns about environmental impact due to high energy consumption. In this work, we introduce BitNet, a scalable and stable 1-bit transformer architecture designed for large language models. Specifically, we introduce BitLinear as a drop-in replacement of the NN linear layer in order to train 1-bit weights from scratch. Experimental results on language modeling show that BitNet achieves competitive performance while substantially reducing memory footprint and energy consumption, compared to state-of-the-art 8-bit quantization methods and FP16 transformer baselines. Furthermore, BitNet exhibits a scaling law akin to full precision transformers, suggesting its potential for effective scaling to even larger language models while maintaining efficiency and performance benefits. 4K 4D, real-time 4D, view synthesis at 4K resolution. This paper targets high-fidelity and real-time view synthesis of dynamic 3D scenes at 4K resolution. Recently, some methods on dynamic view synthesis have shown impressive rendering quality. However, their speed is still limited when rendering high-resolution images. To overcome this problem, we propose 4K 4D, a 4D point cloud representation that supports hardware rasterization and enables unprecedented rendering speed. Our representation is built on a 4D feature grid so that the points are naturally regularized and can be robustly optimized. In addition, we design a novel hybrid appearance model that significantly boosts the rendering quality while preserving efficiency. Moreover, we develop a differentiable depth peeling algorithm to effectively learn the proposed model from RGB videos. Experiments show that our representation can be rendered at over 400 FPS on the DNA rendering dataset at 1080p resolution and 80 FPS on the eNerf outdoor dataset at 4K resolution, using an RTX 4090 GPU, which is 30 times faster than previous methods and achieves the state-of-the-art rendering quality. We will release the code for reproducibility. VeRA, Vector-based random matrix adaptation. Low-rank adaptation LoRa is a popular method that reduces the number of trainable parameters when fine-tuning large language models, but still faces acute storage challenges when scaling to even larger models or deploying numerous per-user or per-task adapted models. In this work, we present vector-based random matrix adaptation, VeRA, which reduces the number of trainable parameters by 10 times compared to LoRa, yet maintains the same performance. It achieves this by using a single pair of low-rank matrices shared across all layers and learning small scaling vectors instead. We demonstrate its effectiveness on the GLUE and E2E benchmarks and show its application in instruction following with just 1.4 million parameters using the Llama 27B model. Set-of-mark prompting unleashes extraordinary visual grounding in GPT-4V. We present Set-of-Mark SOM, a new visual prompting method, to unleash the visual grounding abilities of large multimodal models, LLMs, such as GPT-4V. As illustrated in Figure 1, right, we employ off-the-shelf interactive segmentation models, such as SAM, to partition an image into regions at different levels of granularity and overlay these regions with a set of marks, for example alphanumerics, masks, and boxes. Using the marked image as input, GPT-4V can answer the questions that require visual grounding. We perform a comprehensive empirical study to validate the effectiveness of SOM on a wide range of fine-grained vision and multimodal tasks. For example, our experiments show that GPT-4V with SOM outperforms the state-of-the-art, fully fine-tuned referring segmentation model on RefCoCog in a zero-shot setting. TEAK, Trainable Equivalent Transformation for Quantization of LLMs. As large language models, LLMs, become more prevalent, there is a growing need for new and improved quantization methods that can meet the computational last layer demands of these modern architectures while maintaining the accuracy. In this paper, we present TEAK, a trainable equivalent transformation that preserves the FP32 precision of the model output while taking advantage of low-precision quantization. especially 3 and 4 bits weight-only quantization. The training process is lightweight, requiring only 1K steps and fewer than 0.1% of the original model's trainable parameters. Furthermore, the transformation does not add any computational overhead during inference. Our results are on par with the state-of-the-art SOTA methods on typical LLMs. Our approach can be combined with other methods to achieve even better performance. The code is available at the project's website. Context-aware meta-learning. Large language models like ChatGPT demonstrate a remarkable capacity to learn new concepts during inference without any fine-tuning. However, visual models trained to detect new objects during inference have been unable to replicate this ability and instead either perform poorly or require meta-training and/or fine-tuning on similar objects. In this work, we propose a meta-learning algorithm that emulates large language models by learning new visual concepts during inference without fine-tuning. Our approach leverages a frozen pre-trained feature extractor and, analogous to in-context learning, recasts meta-learning as sequence modeling over data points with known labels and a test data point with an unknown label. On 8 out of 11 meta-learning benchmarks, our approach, without meta-training or fine-tuning, exceeds or matches the state-of-the-art algorithm, PKMGF, which is meta-trained on these benchmarks. EvalCrafter, benchmarking and evaluating large video generation models. The vision and language generative models have been overgrown in recent years. For video generation, various open-sourced models and public available services are released for generating high visual quality videos. However, these methods often use a few academic metrics, for example, FVD or IS, to evaluate the performance. We argue that it is hard to judge the large conditional generative models from the simple metrics, since these models are often trained on very large datasets with multi-aspect abilities. Thus, we propose a new framework and pipeline to exhaustively evaluate the performance of the generated videos. To achieve this, we first conduct a new prompt list for text-to-video generation by analyzing the real-world prompt list with the help of the large language model. Then we evaluate the state-of-the-art video generative models on our carefully designed benchmarks in terms of visual qualities, content qualities, motion qualities, and text caption alignment with around 18 objective metrics. To obtain the final leaderboard of the models, we also fit a series of coefficients to align the objective metrics to the user's opinions. Based on the proposed opinion alignment method, our final score shows a higher correlation than simply averaging the metrics, showing the effectiveness of the proposed evaluation method. Approximating two-layer feedforward networks for efficient transformers. How to reduce compute and memory requirements of neural networks, NNs, without sacrificing performance. Many recent works use sparse mixtures of experts, MOEs, to build resource-efficient large language models, LLMs. Here we introduce several novel perspectives on MOEs, presenting a general framework that unifies various methods to approximate two-layer NNs. For example, feed-forward blocks of transformers, including product key memories, PKMs. Leveraging insights from this framework, we propose methods to improve both MOEs and PKMs. Unlike prior work that compares MOEs with dense baselines under the compute equal condition, our evaluation condition is parameter equal, which is crucial to properly evaluate LMs. We show that our MOEs are competitive with the dense transformer XL on both the Wikitext 103 and in Wiki 8 datasets at 2 different scales, while being much more resource efficient. This demonstrates that MOEs are relevant not only to extremely large LMs, but also to any scale resource-efficient LMs. Our code is public. LAMP. Learn a motion pattern for few-shot-based video generation. With the impressive progress in diffusion-based text-to-image generation, extending such powerful generative ability to text-to-video raises enormous attention. Existing methods either require large-scale text-video pairs and a large number of training resources, or learn motions that are precisely aligned with template videos. It is non-trivial to balance a trade-off between the degree of generation freedom and the resource costs for video generation. In our study, we present a few-shot-based tuning framework, LAMP, which enables text-to-image diffusion model learn a specific motion pattern with 8 to 16 videos on a single GPU. Specifically, we design a first-frame conditioned pipeline that uses an off-the-shelf text-to-image model for content generation, so that our tuned video diffusion model mainly focuses on motion learning. The well-developed text-to-image techniques can provide visually pleasing and diverse content as generation conditions, which highly improves video quality and generation freedom. To capture the features of temporal dimension, we expand the pre-trained 2D convolution layers of the T2I model to our novel temporal spatial motion learning layers and modify the attention blocks to the temporal level. Additionally, we develop an effective inference trick, shared noise sampling, which can improve the stability of videos with computational costs. Our method can also be flexibly applied to other tasks, for example, real-world image animation and video editing. Extensive experiments demonstrate that LAMP can effectively learn the motion pattern on limited data and generate high-quality videos. The code and models are available at the project's website. CrossCodeEval, a diverse and multilingual benchmark for cross-file code completion. Code completion models have made significant progress in recent years, yet current popular evaluation datasets, such as HumanEval and MBPP, predominantly focus on code completion tasks within a single file. This oversimplified setting falls short of representing the real-world software development scenario where repositories span multiple files with numerous cross-file dependencies, and accessing and understanding cross-file context is often required to complete the code correctly. To fill in this gap, we propose CrossCodeEval, a diverse and multilingual code completion benchmark that necessitates an in-depth cross-file contextual understanding to complete the code accurately. CrossCodeEval is built on a diverse set of real-world, open-sourced, permissively licensed repositories in 4 popular programming languages: Python, Java, TypeScript, and C#. To create examples that strictly require cross-file context for accurate completion, we propose a straightforward yet efficient static analysis-based approach to pinpoint the use of cross-file context within the current file. Extensive experiments on state-of-the-art code language models like CodeGen and StarCoder demonstrate that CrossCodeEval is extremely challenging when the relevant cross-file context is absent, and we see clear improvements when adding this context into the prompt. However, despite such improvements, the pinnacle of performance remains notably unattained, even with the highest performing model, indicating that CrossCodeEval is also capable of assessing the model's capability in leveraging extensive context to make better code completion. Finally, we benchmarked various methods in retrieving cross-file context and show that CrossCodeEval can also be used to measure the capability of code retrievers.